You are taught to imagine the universe as an explosion, a single point, a cosmic detonation that flung galaxies outward into empty space. It feels intuitive. If everything is moving away from everything else, there must have been a place it all began, a center, a starting mark on the map of existence. But there isn't one. That isn't poetic exaggeration. It's not philosophical metaphor. According to our best cosmological models, the universe has no center anywhere in space, not hidden, not far away, not beyond what we can see, nowhere. And yet everything moves. Look at the galaxies through a telescope and you find something unsettling. Nearly all distant galaxies are receding from us. The farther they are, the faster they appear to move away. It feels obvious what that means. We must be near the middle. Everything is flying outward from some original point, and we happen to be somewhere close to it. If you moved to a galaxy billions of light years away and looked around from there, you would see the same pattern. Distant galaxies would be moving away from you. And from that location, it would again appear that you were at the center. You think motion requires a reference point. You think expansion requires a location to expand into. But the universe does not obey that intuition. There is no cosmic bullseye. The mistake is subtle but profound. We imagine the universe expanding the way shrapnel expands through air, an explosion into pre-existing space. But that image is wrong. The universe is not expanding into anything. Space itself is expanding. That sounds like a semantic trick, but it isn't. When space expands, every region stretches, every distance grows. There is no privileged location where the stretching began. It happened everywhere at once, not at a point in space, but at a moment in time. You think there must be a center because every explosion you've ever seen has one. But the universe is not exploding inside something larger. There is no outside, no external stage, no boundary to step beyond. This destabilizes more than geometry. It destabilizes your sense of orientation. If there is no center, then there is no fixed anchor. If there is no anchor, then what does moving even mean? We say galaxies are moving apart, but moving relative to what? If space itself stretches, are galaxies traveling through space, or is the space between them simply growing? This is where intuition starts to fracture, because if there is no center, and no outside, and no absolute background, then motion cannot mean what you think it means. And yet, everything moves. So the real question is no longer where the universe began. The real question is deeper and more uncomfortable if there is no central point pulling or pushing. Why does anything drift apart at all? To understand why the universe has no center yet everything moves, you have to let go of the way explosions behave. Imagine drawing dots on the surface of a balloon. Each dot represents a galaxy. Now begin inflating the balloon. As the rubber stretches, every dot moves away from every other dot. From the perspective of any single dot, it appears that it sits at the center of expansion. Every other dot is receding, but none of them are the center. The center of the balloon is not on the surface at all. It exists in a higher dimension the dots cannot access. To creatures living purely on that surface, there is no central location. There is only increasing distance. You think expansion must happen from somewhere. But on the balloon's surface, expansion happens everywhere at once. The analogy isn't perfect, but it reveals something crucial. Galaxies are not racing outward through a static void. Instead, the space between them is stretching. The motion we observe is not like debris flying through air. It is more like the rubber itself elongating. This reframes what we mean by movement. When you walk across a room, you move relative to the floor. When a car drives down a highway, it moves relative to the ground. We are used to motion happening against a fixed backdrop. There is always something still, but on cosmic scales, there is no universal floor. We measure galactic motion using light. As galaxies recede, their light stretches, shifting toward the red end of the spectrum. This red shift grows stronger with distance. The farther away a galaxy is, the faster it appears to move away. This relationship is not random. It is systematic. You might expect that galaxies near some central point would move fastest, like fragments from a bomb. But observations show something different. Every observer in every galaxy would measure the same pattern, distant galaxies receding faster than nearby ones. That only makes sense if expansion is uniform. It feels counterintuitive because we imagine space as empty nothingness, a static stage where matter performs its motion. But in modern cosmology, space is dynamic. It can stretch, it can curve, it can evolve. So when we say galaxies are moving apart, we are using everyday language to describe something stranger. The galaxies are mostly staying where they are locally. It is the metric of space itself that changes. This leads to a deeper discomfort. If everything is moving away from everything else, then there is no fixed reference point anywhere in the universe. There is no cosmic rest frame that defines absolute stillness. You think motion requires an origin. But here, motion arises from geometry. The expansion does not radiate outward from a special location. It is embedded into the structure of space at every location. There is no edge to approach, no center to retreat from, only increasing separation. And yet the balloon analogy hides something important. The balloon expands into surrounding air. The universe does not expand into anything. There is no outside dimension into which we can step to see the whole shape. The balloon model helps your intuition briefly, then fails at the most critical moment, because the universe is not a surface embedded in something larger. It is all there is. So if there is no center in space, and no external container, and no fixed backdrop, then what is actually driving this expansion? Why does space stretch at all? To understand why the universe expands without a center, you have to stop imagining space as a container and start seeing it as a participant. For most of human history, space was treated as emptiness, a passive stage. Matter moved. Space remained indifferent. Even after Isaac Newton described gravity with astonishing precision, space itself was still considered fixed. Absolute motion happened within it. But that picture did not survive the 20th century. When Albert Einstein developed general relativity, he overturned the idea that space was merely background. In his framework, space and time fuse into a dynamic entity, space-time. And space-time is not rigid. It bends, it curves, it evolves. You think gravity pulls objects together across empty space. But in general relativity, objects follow the curvature of space-time itself. Matter tells space-time how to curve. Space-time tells matter how to move. Now extend that idea to the entire cosmos. If space-time can curve locally around stars and galaxies, it can also curve globally. The geometry of the universe as a whole can change over time. The expansion we observe is not galaxies blasting outward from a point. It is space-time itself stretching. The equations of general relativity allow for this naturally. In fact, when Einstein first applied them to the universe, they predicted expansion or contraction. He resisted this implication and introduced a cosmological constant to force a static universe. Later observations revealed he did not need to force it at all. The equations were already telling the truth. The expansion does not require a center because it is not an explosion inside space. It is an evolution of space. Imagine a grid drawn across the universe, marking distances between galaxies. As time progresses, the spacing between grid lines increases. The galaxies are not racing through the grid. The grid itself is scaling up. From any galaxy's perspective, all distant galaxies drift away. You think movement must have direction, but cosmic expansion has no preferred direction. It has no axis, no orientation. It is uniform. This uniformity is key. If expansion were stronger in one region than another, we could trace motion backward to a central location. But observations show remarkable isotropy. On large scales, the universe looks the same in every direction. That symmetry is not decorative. It is structural. The early universe, according to cosmology, was incredibly dense and hot. not concentrated at a single point in space, but concentrated everywhere. The Big Bang was not an explosion from a location. It was a moment when space-time itself was compressed to extreme density across all regions simultaneously. You think beginning implies a place, but here the beginning was a time. This reframes the entire question. If there is no center in space, it is because the expansion does not originate from a spatial coordinate. It originates from initial conditions embedded in space-time's geometry. And yet, this only deepens the mystery. Why did space-time begin expanding? What determines whether the universe expands forever, slows down, or collapses? The equations describe how expansion evolves based on energy density, matter, radiation, and dark energy. But the existence of expansion itself arises from the structure of the equation. Space-time is not static by default. Under general relativity, dynamic evolution is natural. You think stillness is fundamental and motion is secondary. But cosmology suggests the opposite. Change is built in, even more unsettling. There is no absolute frame of reference against which the universe's expansion can be measured from outside. There is no external ruler, no external clock. The expansion is defined internally, relationally, through distances between galaxies. This is motion without a background. It means that asking, where is the center, is like asking, on the surface of Earth, which point is the middle of north. The question presumes a structure that does not exist. The universe has no center because its geometry does not contain one. It expands because its space-time solution evolves that way under its own energy content. But this expansion is not just a slow drifting apart of galaxies. It shapes the fate of stars, the formation of structure, and the ultimate destiny of everything. To see that, you have to zoom out even further. When you zoom out far enough, the expansion of the universe stops feeling abstract and starts becoming architectural. Galaxies are not scattered randomly. They form clusters. Clusters form superclusters. Vast filaments of matter stretch across hundreds of millions of light years. Weaving a cosmic web between those filaments lie enormous voids, regions almost empty. This structure emerged because gravity worked against expansion. In the early universe, matter was distributed almost uniformly. Tiny fluctuations, barely measurable variations in density became seeds. Gravity amplified them. Slightly denser regions pulled in more matter. Over billions of years, those small imbalances grew into galaxies and clusters. You think expansion should tear everything apart uniformly. But locally, gravity can overpower expansion. Within galaxies, stars remain bound. Within clusters, galaxies orbit one another. The space inside these systems does not expand in the same way the vast cosmic distances do. Expansion dominates on large scales. Gravity dominates on smaller ones. This balance shapes the universe's architecture, but the expansion itself has not remained constant. Observations of distant supernovae in the late 20th century revealed something unexpected. The universe is not just expanding, its expansion is accelerating. You might expect gravity to slow expansion over time. More matter means more attraction. But measurements showed the opposite trend. Distant galaxies are not merely drifting away. They are receding faster than predicted by matter alone. This implies the presence of something else, an energy intrinsic to space itself. Often called dark energy, it behaves like a property of space-time that drives accelerated expansion. You think space is empty, but if dark energy is real, empty space contains energy that influences cosmic dynamics. The result is profound. As expansion accelerates, distant galaxies will eventually recede so quickly that their light can no longer reach us. They will fade beyond a cosmic horizon, not because they traveled through space too fast, but because the space between us stretches too rapidly. There is no center from which they escape. There is no edge they approach. There is only increasing separation embedded into geometry. Imagine an observer in a galaxy billions of years in the future. Most of the galaxies we see today will have vanished from their observable universe. From their perspective, the cosmos will appear emptier, more isolated. The large-scale web will thin. You think motion implies travel across a map. But on cosmic scales, the map itself evolves. And still, there is no preferred location. Every galaxy sees others receding. Every observer can define themselves as stationary relative to their local surroundings. Motion remains relative. The expansion does not single out a privileged vantage point. Even the cosmic microwave background, the afterglow of the early universe, appears nearly uniform in every direction, reinforcing the idea that the universe has no geometric center within itself. What we experience is not an explosion unfolding in space. It is space-time stretching in accordance with its own internal rules. This shifts the question from where is the center to something deeper. Why does the geometry of the universe allow this at all? Why is space-time structured so that expansion is natural? Why does its large-scale curvature evolve? Because once you accept that the universe has no center, you are forced to confront a more radical realization. Motion is not happening inside reality. Motion is part of how reality is built. It is tempting to believe that somewhere hidden beyond our horizon, there must be a privileged point, a cosmic origin in space, a place where the expansion began and from which everything still flows outward. But that desire says more about human intuition than about the universe. We are creatures of surfaces and edges. Every room has walls. Every explosion has a source. Every map has a middle. We instinctively search for anchors because our everyday world always provides one. The universe does not. There is no central coordinate embedded in space-time, no universal landmark that defines the middle. The expansion does not point back to a location. It points back to a time. That distinction matters. When cosmologists describe the Big Bang, they are not describing matter erupting from a point into empty surroundings. They are describing an early state when space-time itself was compressed to extraordinary density everywhere at once. The beginning was not somewhere. It was when you think the absence of a center makes the universe chaotic. But in fact, it reveals symmetry. Every location is equivalent on large scales. No galaxy occupies a special geometric throne. The laws of physics apply uniformly. The expansion treats all observers the same. This universality is unsettling because it removes the comfort of perspective. There is no vantage point from which the entire cosmos can be surveyed externally. There is no outside reference frame. The universe does not expand into anything, and it does not expand from anywhere. It simply expands. That realization reframes motion itself. We often imagine ourselves traveling through space, navigating a stable backdrop, but at the deepest level, even the backdrop evolves. Distances change, not because objects push through emptiness, but because the metric defining those distances transforms over time. In that sense, the universe is not a thing placed within a larger container. It is the totality of space-time and its contents. There is no higher stage behind it. The absence of a center is not a missing feature. It is a structural fact of geometry. And once you accept that, the original question shifts. The universe moves not because it was flung outward from a location, but because its geometry unfolds according to physical law. Expansion is not an event that happened somewhere long ago. It is an ongoing property of reality. You are not watching debris drift from a distant origin. You are living inside a space-time whose fabric stretches. The universe has no center, yet everything moves, not outward from a point, but forward through a geometry that refuses to stand still.